Hello. We are going to delve into a new topic, which is function pointers and Lambda functions, related in some ways, but in particular, this can be very, very useful if you don't want to have to go out of your way to write a whole function outside of where you're working, and you just kind of want to get stuff going right away. So there's some convenience to being able to use these things. Much like some other topics in this course, there's nothing that this is going to be able to teach you to do that you couldn't do already in some other way. However, this offers a bit more of a convenience when it comes to being able to use functions in different ways. So up to this point, every function that we've written is something we have to define all on its own. Sometimes we declare it and then define it, and then we call it later. But sometimes it's actually the case that you're writing some code and you realize, hey, I just need a function for this one thing right here. Maybe I need a loop that's going to call a function a bunch of times. And I don't really want to have to go and define that function somewhere else because I actually don't want anybody to use that function except me right now, right here. And we're going to go over how you can do that today. So our first exercise is to define a function pointer. A function pointer, just like any other pointer, points to something in memory, just that instead of this being data, I mean, kind of technically is still data, it's just that the data happens to, instead of being some numerical value, is a set of instructions, that set of instructions being a function. Now, the function pointer is going to be named fashion designer, and it's going to represent a designer trying to make some clothes. And these functions that can be pointed to by fashion designers are going to refer to different styles. So you could take a style such as streetwear, pass it a string representing an outfit, and then we'll make a streetwear outfit of that kind. So we'll do something simple here where we're just going to print some stuff. But the idea here is that our function pointer will be a fashion designer who can point to all kinds of different functions. All those functions need to take a string, and they're going to just print out a message, so they're going to be void functions. So let's see if we can get this going. Okay, so example 1. Okay. Now, before we begin, of course, we need to include IOStream, because we're going to need some strings. Now, here is something that's going to save you a lot of time in the future. Very often when you're working with function pointers, the type that describes what a function is can be very, very messy. Sometimes you have to write something really, really long and convoluted because if you want to make a function pointer, the type of the function pointer has to match what kinds of function it's going to point to. You can't have a function pointer, for instance, that points to one function that returns an integer and another returns a string. These are not compatible. So every function pointer you have has to specifically indicate what kind of function it points to. So rather than having to write out that whole description every single time, I'm just going to do it once. But I'm going to use typedef so that every time that I use the word fashion designer, I'm referring to something specific. And what I'm referring to is going to be a void function. It's a function pointer, so I'm going to wrap the name function fashion designer inside of parentheses and put a star before it to indicate this is a pointer. It returns void, and it's going to take as a parameter a string. And in this case, we'll use constant string reference. Because in general, we would prefer to point to the strings. We'd prefer not to actually pass the strings because sometimes it can be very long. So this really messy looking thing here allows me to now just use the word fashion designer anytime I want to point to one of these different functions. So now I can just make my streetwear function. Streetwear, it's going to take one of these strings. This will be the outfit. And we'll say, new streetwear outfit, end line. Just something basic, just so we can kind of see how this works. But now in our main function, what we can do is we can make a fashion designer. We can call them Gucci, whatever you feel like. And now we can assign Gucci to be equal to streetwear. And this is literally saying, okay, this pointer here, because remember, a fashion designer is a kind of pointer, a function pointer. It's now going to point to streetwear. It's been given essentially the address of these instructions. The instructions not being too complicated, print out a message. Which means now, however, I can do something like, outfit equals t-shirt and jeans, being very fashionable. And I can literally do Gucci parentheses outfit. And so kind of the nice modularness of this is that right now Gucci is pointing to streetwear, but later I can have Gucci point to high fashion or whatever other thing. Now when I run this, compile, run, new streetwear outfit, t-shirt and jeans. Exactly what you expect, right? I pass the outfit, and even though I have it saying here Gucci, Gucci is the streetwear function, which means I can pass it whatever I want. I can change this to be something else, pass another thing. It just gives me a little bit of flexibility, which is kind of the whole point. All right, so that's exercise 1, and then we can move on. Okay, so the next exercise says make an array of function pointers that can showcase different fashion design aspects like haute couture, streetwear, evening gowns, casual wear. Allow the user to choose which fashion aspect to showcase and execute it using the appropriate function pointer. Okay, so we're going to build off of what we have. I'll make some changes to it. So the first is we'll do something a little different than typedef, just so you can see an example of another way that you might want to do this. In older versions of C++, particularly also just using C, you'll see typedef show up a lot because older versions of C++ only allowed this to be the one way that you can redefine what a word meant. So I can say something like, what is a fashion designer? Well, it's a void function that takes a string. Newer versions of C++, including the one that we're using for this course, allow us to use the using directive, which should be familiar to you by now. And it works very much the same way. However, the formatting is very, very different. It's going to serve us the same purpose, namely, whoops, did not mean to do that. Namely, it will allow me to assign what it means to be a fashion designer. But in this case, I have to actually include another library called functional, which will allow me to declare a fashion designer to be a kind of function from the standard library. Now, what kind of function is it? Well, I need some triangular brackets, and I need to specify. In this case, we know it is a void function that takes a constant string reference. Okay, so both of these are, I would say, equally valid. They are both ways that can be used to make a fashion designer function pointer. And you can see if I compile this, it does literally the same thing. But just so you have a little reference for both of these, I'll leave them in there. Okay, so right now we can make streetwear, but we can't do any of the other ones that we said we have to do. So let's go through making each of those, and they're all going to look basically the same. So one of them is called haute couture. And then this one will be evening gown. And what was the last one? It was casual wear. Okay, and right now, I just have the one pointer that's pointing to streetwear, and this is like not really useful in any sense. But what I can do is I can say, okay, let's make a an array of function pointers. So we'll say designers. We'll make an array of them, and the 4 that we're going to have are just going to be these functions: streetwear, gown, and casual wear. Oh. Now I can prompt the user which one they want. We'll choose a style. One, streetwear. 2, couture. 3, evening gown, and 4, casual wear. And we'll get their we'll get their input into an integer, and then you can use that to directly index the one that we want. So we'll get their input, cin into the input. So now I've gotten their style that they've chosen. And then I can ask them for an outfit. What is the outfit? And now I need a string outfit. And we'll I think I want to use get line here, just because if they put in, like t-shirt and jeans, I want to make sure I get all of the words. And we're going to take that from cin and put it into our outfit. And then we're going to call designers input -1. So remember, if they pick streetwear, they put in 1, and I want it to be 0. So we'll take that, reduce it by 1, so we have the correct function pointer, and then pass it the outfit. And see, this is so much cleaner than what we may have had to do back in CSCI 1060, which is we probably would have made a big if statement that says, if they put in 1, then do this. If they put in 2, then do this. And it's so messy and ugly, when in here I can just do it very, very quickly and cleanly. So let's try this out. G++ exercise 2. Oh, what did I mess up? Right, I forgot to do std::cin right here. All good. Okay, let's pick a evening gown. Oh, it does not seem to be happy with that, and that's probably because I need to flush the input buffer. I suppose I can use getLine for both of these, is one way to get around that. So here, what if I use input over this way? Oh, was it really unhappy there? That's odd. But I saved this. See, yeah, I changed that. Line 34. Yeah, it's fixed. It's right there. Oh no, hold up. It's a different error. No matching call for. Oh right, because it's trying to put this as a string when it's just a number. So we'll need to convert the string into an integer. How is that? Are you happy now? I'm still unhappy, huh? Why is that? Okay, how about we do it one step at a time, where we get this as a string first. Okay, no, this is getting annoying. How do I flush the buffer again? I always forget. It's clear. Oh, ignore. Something like this. Let's see if that fixes it. I always forget how to flush the buffer. It's very annoying. Okay, there we go. What is the outfit? Ball gown. Sure, why not? New evening gown, outfit, ball gown. And now I can still do something like casual wear, ball gown. It's a very, very casual outfit, of course. Okay, so just had to fix this annoying thing. Anytime that you're mixing up cin and getLine, you're always going to have these issues of the input buffer because of the remaining new line characters and stuff. So just to prevent that, I'm going to flush the buffer here. Flush input buffer. And that way I can read in my integer, because I really want to make sure that the number I'm reading in is going to be one of these, something I can use to convert into 1, 2, 3, 4. Which is why I'm, or not 1, 2, 3, 4, 0, 1, 2, 3. Since it's 1, 2, 3, 4, I have to subtract by 1 every time to get the correct index, and then I just pass it the outfit. And then all this code is like really, really short and simple for what could have been something much, much longer. So great. All right, now we can move on. Okay, so next one. Write a function that takes a fashion design function pointer as one of its parameters. The function should iterate through a array, oh, it says array, it should be a vector, of outfits, and apply the provided fashion designer function pointer to each outfit. So let's give this a shot. And I think if we do this correctly, it should actually be very easy. Okay. Here's what we're doing. So we already have our fashion styles. We have our fashion designer function pointer set up. Right now we're just letting people pick some things, but I think we're going to change that. So here's what we're going to do: is we're going to comment all this out because this is all from before. Now it says that we need a function that's going to take a vector of outfits and apply the fashion designer function pointer to each outfit. So now, I believe it's a void function. Doesn't sound like it's going to do anything. And this is going to, apply fashion designer. It is going to take a vector of outfits, and it seems like outfits are strings. So it's a vector of this. So vector of these called outfits, and it's going to take a fashion designer, which we'll call F for creativity. And the code for this is actually very simple. For outfit in outfits F outfit. Look how simple, right? It's obviously this looks like not the cleanest because there's a whole bunch of stuff going on in here, but the code for this function is really, really short. For each outfit, in my outfits, apply the fashion designer to the outfit. Boom, done. Nice. So let's get some outfits. Outfits. Let's see, t-shirt and jeans. Tailored suit. Ballroom gown. Hoodie and sweats. And now I will apply fashion designer. Oh yeah, sorry. This is a array, but I wanted this to be a vector. So vector of these. I think this should still work if I'm not mistaken. I think I can still use the curly braces to initialize like this, if I remember correctly. Otherwise, I'll have to fix it. But we're going to pass the outfits. We're going to pass, let's just say streetwear for fun, and see what happens. Compile. Okay, what I messed up this time? It's unhappy because there's some wacky errors here. Can I see something that refers to my actual code? I think it has to do with the vector initialization, perhaps. Or maybe not. It might be that I can't have the constant inside the vector. I think that's probably the issue. So let's drop that and see if that helps. Yeah, let's see. Can't tell. Oh, did I not include the ampersand somewhere? Right, this should be ampersand here. I think. Is that right? Making me second guess myself. It should have the match at least. Let's try that. Ah, okay, there we go. So I got rid of the ampersand here and also here. Here it makes sense. Like I can't put a reference in because I'm literally defining them all right now. And then when I call apply fashion designer, I think I'm going to have to pass the vector itself, and the vector is going to contain the actual strings. But that's okay. Each outfit then is grabbed by reference, which is fine. And do we work? I hope so. Yeah, there's my new streetwear outfits. Wear our ballroom gowns on the street now. Sounds good to me. And yeah, great. So the code here is nice and really, really condensed, rather than having to, as I mentioned before, write all these giant if statements and such. I can just have one vector that contains all my outfits. I can pass all those outfits to a single function, and then for each outfit in there, I can apply my function, which in this case just prints, but you can imagine it could do other things too, to my streetwear function to every outfit in that vector. Really nice. So gives me some modularity. I can switch up this. Instead of streetwear, this can be something else. Instead of these outfits, it can be some other outfits. I got some options in what I can do here. I don't have to do too much work to change it. Great. Okay, on to the next one. All right. Define a function pointer named runway model representing a model's walk on the runway. The function should take a model's name and outfit description and print a runway walk message. Implement an array of models and use function pointers to simulate each model's walk. Okay, so we'll probably need some new code for this. I think I'll actually just make a brand new file. ex4.cpp. Oops. Okay, so I need a function pointer called runway model. It is going to be it looks like it's a void function as well. And it's going to take, so what was my format? Yeah, 2 strings, one for the name and one for the outfit. So it's a void function that takes a string and another string. We need IOStream and we need functional. IOStream for string, functional for the function type. Okay. So this is my function pointer. We need to do walk, something to actually do the walking down the runway. So we'll do walk on runway. And obviously it's going to need these strings. So we'll just steal them. And this will be the name. And this will be the outfit. And we're just going to, again, print a message saying name is walking on the runway while wearing outfit. Okay, cool. So there's my function. Now I need to make an array of models. So I guess we're going to go with names. And we're probably going to need to have, maybe we'll just give them all the same outfit. Or no, we'll make different outfits. So in our main, let's see here. We need an array of models. String models. And we'll do, who are famous models? I don't know anything about modeling. Okay. We're going to go with literally the top 3 because I don't know any better. So, Cindy Crawford, Kate Moss, Naomi Campbell. Sure. These are our models. Now we need our outfits. And we'll go with ballroom gown, fashionable, tailored suit, and t-shirt and jeans. Why not? The height of fashion, of course. Okay. And then what we can do is, okay, so use function pointers to simulate each model's walk. So what I can do is for I0, well, first actually I need my runway model. Runway model, runway equals walk on runway. Yeah, sounds fine. I equals 0, I less than 3, I plus plus. We can do, so runway, and we're going to pass it models I, and we'll pass it outfits random modulo 3. And so that way we get like 3 random outfits that we pass, 1 for each model. I think that sounds fine to me, just to see what happens. Oh, we need a space in there to make this look a little less ugly while wearing. There we go. Tailored suit, ballroom gown. Nice. Hey, there we go. Just a little bit of another demonstration of how you might want to use this for sure. Another option is you could also make an array of different ways to walk down the runway. I suppose I could do something like this. Sashay on runway. Sashaying on the runway while wearing. And then to randomize which of these that they do, so this will be our runway walks array is going to contain run on walkway and sashay on runway. And then instead of calling runway, we can do runway walks, and the index can also be random, modulo 2. And so now I can randomly pick which function I'm going to call. For that function, I pick the model, and then I also randomly pick the outfit they're wearing. So now we got a bit more, unpredictability perhaps. So now it turns out all 3 of them are sashaying. Can we get a little better randomness perhaps? Let's include time. Let's see if we can get something a little better. There we go. So sometimes walking, sometimes sashaying. The outfits are completely randomized, changing literally every time. A bit of variation is always nice. But now you can do that without having to, again, deal with all these if statements. In a single line, I can randomly select a function, randomly select an outfit, and iterate through our models. Nice and clean. All right, moving on. Okay. Define a lambda function, which calculates a fashion quotient for a given outfit. And a fashion quotient is a random number between 1 to 100 plus the length of the outfit string. Very normal. Use the lambda function to calculate and display the fashion quotient for a user inputted outfit. Okay. So we'll make a new one for this, I think. Example 5. Here's what we have to do. We're going to make a lambda function. So a lambda function is essentially a function that only is defined within the scope of another function. As soon as that function is over, you can't access it anymore. And so I'm going to make that lambda function first. Now, what is my, the type of this? So we've seen that we can use function. Again, we're going to need some libraries to help us out. Functional. So it is a function. In particular, it is, so let's see, it's going to give us a fashion quotient, which is an integer, and the parameter is going to be a string. Now, so this is the type. The name of my function we'll call fashion quotient. And when you're creating a lambda function, you're going to need 3 things. You need your captures, you need your parameters, and you need your code itself. So before I write any of my lambda functions, I like to actually just put these things in order because that helps me to remember what things I don't want to forget. Now, we're not going to capture anything right now. We're not doing anything like that for this exercise, but in another one, we'll show you what you can capture. The parameters here are going to be the outfit. So this is going to be outfit. And the code here says we're going to get a random number. So this is going to be our result. Is a random number from 1 to 100. And then result plus equals outfit.length. And return the result. So now we have created a Lambda function, a function within another one, that allows us to calculate a fashion quotient for a user input outfit. So now we need an outfit. Please enter an outfit. Get line, cin, outfit. So we're going to get their outfit. FQ is going to be fashion quotient called upon the outfit that they put in. And then we'll write out outfit has a fashion quotient of FQ. Okay, really short program, but I think it should do what we're looking for. Let's try it out. Okay, we made a mistake. What did we mess up? Oh, I have I've declared this incorrectly. You're supposed to have an equal sign here. It is a Lambda function. I'm not making this some kind of array. Let's try that again. Oh, what did I mess up here? Expected a semicolon before std. Which line is this? Please enter an outfit. Oh, here. Got to remember that this is an assignment statement. I'm creating a variable called fashion quotient. It is a Lambda function, which means it's going to be assigned a function. It has a type, and I need a semicolon to terminate the statement. Okay, there we go. Nice. Go. My outfit is a onesie. A onesie has a fashion quotient of 90. Hooray! Since I didn't randomize this properly, I should be able to get 90. So that means that my random number it's generating should be 84. So let's say that I put in something simpler like jeans. Then I believe it should be 2 smaller, 1 smaller. Right, because I forgot the S in jeans. There we go. Okay, so just to reflect on what we've written, our Lambda function, here is what it's called, fashion quotient. Its type is a function that returns an integer parameter and accepts a string as an argument. It does not capture anything, which we'll get to. The parameter is a string one called outfit, and then here is the code for it, and that's it. And now down below, when I want to call my fashion quotient function, I can do so as though I had declared it as a normal function. And outside of main, fashion quotient does not exist. You cannot access it whatsoever. All right, moving on. Okay. Set a variable in your main function that is the current year. Remove the randomness from your Lambda function. Instead, add a bonus to the fashion quotient equal to the current year modulo 100 by capturing the year variable. So we're going to capture a variable this time. There's a number of different ways you can do it. We're just going to show one in this exercise. Okay. Now, if you want to be nice and formal, you can always write code that will actually get the current year, but I am just going to say the year is 2024, because that's when I'm coding this. Now, this year is not actually available inside the fashion quotient function. Right now, the only thing that's available is the outfit, no other variables. I can make some, but I can't grab any from outside. If I want to capture one of these variables, I need to capture it inside of here by stating, hey, give me the year. You can pass it by value. You can capture it by value. You can capture it by reference, which is what we'll do. And now, inside, anytime that I call fashion quotient, it's going to access this year variable and get whatever the value is, because I have said get it by reference. If I say get it by value, it's just going to put 2024 in here as a substitute. Okay, so my result is going to be now the year modulo 100. And that's going to be the bonus that it gets plus the length of the outfit. Okay. So let's try this out. So that means that we should get a bonus of 24 to our outfits from this year. So if my outfit is jeans, which is 5 letters, and 24 is 24, I should get 29. There it is. Okay, great. So just kind of demonstrating the use of the year here. And now notably, if I decided to change the year down the line, say I make it 2032. Oops, sorry. Year is 2032. I'm going to say jeans. It's now going to go up to 37 because the year has been changed. But if I don't pass it by reference, it will go with the original declaration of the year because it passed the copy of 2024 into here instead of a reference to the year variable. So most of the time, if you're capturing, you probably want to grab by reference. Okay, short and simple. So moving right along. Okay. Create an outfit class that stores name, year, and fashion quotient. Then write a program that leverages the C++ standard library's sort algorithm to organize a collection of outfits based on their fashion quotient ratings in descending order. Okay, so we're going to need to definitely make lots of modifications to this code. And let's go one by one. Step 1, I need an outfit class. That shouldn't be too hard. A class called outfit. Just gonna make everything public. We need a name, a year, and a fashion quotient. And let's make a constructor, and the constructor will give us our fashion quotient. So outfit will take a string n int y n year y, and then we'll use this code from before. Yeah, we can just take this down because now we have the year. Int result is that, and then fashion quotient equals result. I guess I can make it a little cleaner and just make everything, fashion quotient is that. Okay, so I got my outfit class. Write a program that uses the sort algorithm to organize a collection of outfits. I'm going to need a collection of outfits. Let's get a vector. So if I need a vector, I'm going to probably need to include vector. I might not need to. I think I got it to work last time okay, but we'll just do it anyway. So this is going to be a vector of outfits. And I probably want them to be outfit pointers because I don't want to be putting whole outfits in here. Outfits. I guess I can just put in the whole outfit. I don't think we need a pointer. It's fine. Just to simplify this. Actually, is that the cleanest way to do it? Yeah. We're gonna have t-shirt and jeans from 1985. Tailored suit from this year. Ballroom gown, 1887. Onesie, 2010. Sure, why not? Okay, now my goal is to sort these by their fashion quotient. Now, the fashion quotient is going to be basically, well, actually, Yeah, it's interesting because if you're just going by year, ballroom gown would be a higher number than t-shirt and jeans, but I think because t-shirt and jeans is longer and it adds on to the 85, it'll actually come after. So anyway, I don't need to do any of this stuff, so I can go. But now I want to do a sort. So I'm going to call sort. Now, these are the kinds of functions where you would never really memorize exactly how this works. These are the kinds of things you probably would want to look up, so I will look it up. We'll see exactly how it's supposed to function. So, sort is a function from the standard library. It's going to take some iterators, so we're going to need to grab the begin and the end of our vector, just so we can see what it kind of looks like here. So here's a sample of you calling it. From start to the end, sort with the default comparison being less than. Now, here's the thing, is right now you can't compare two outfits. We could overload the less than operator, in which case this would get that to work. But simpler is actually to use a lambda function. And you can see they've actually done that down here with this example, where they wrote a lambda function in here and passed that to the sort function to tell it, here is how you should compare any two things. So we're going to use something like this. So I'm actually going to copy it. But we're going to need to make the appropriate changes. Now, it's not s.begin, it's going to be outfits.begin. Same thing over here. And now for our lambda function, we're not capturing anything because we don't need any variables from here. Instead of integers, we're comparing outfits. So it's going to be outfit A and outfit B. And instead of comparing A greater than B, I want them to be in order if A dot fashion quotient is less than B dot fashion quotient. So if that's been done correctly, now I should be able to iterate through my vector and output them all. Okay, so for outfit O in outfits, sorted. We'll just output the name O dot name and see what order it gives us. So right now it's t-shirt followed by tailored suit followed by ballroom followed by onesie. And if we look at the fashion quotients, remember they're modulo 100 plus the length of the name. So this should be the smallest. It's 10 plus 6. This should be next smallest, 24 plus something, then 87 plus something, then 85 plus something, because the something here is longer. At least it looks like it's longer to me, so I think it is. But we're going to find out. What did I mess up? I meant outfit, yes, not lowercase o. Oh, it's because it's it says outfit.length. It should be name.length. There we are. So sorted, onesie, and yeah, t-shirt and jeans was the highest one because the name of t-shirt and jeans is longer, and then adding on to the 85 compared to the 87 gives us that order we're looking for. So the neat thing here is that we've sort of learned now how we can use this sorting algorithm to our advantage. First of all, I didn't have to write a whole sorting algorithm. That saved me a ton of time. I do need to figure out how to get iterators to the start and end of my collection. So for vectors, it's pretty easy. It's just dot begin and dot end. For other data types, it may vary. And then we use a lambda function. The lambda function explains what does it mean for two elements, A and B, to be in order. And in this case, we say they are in order if A's fashion quotient is less than B's fashion quotient. If that is the opposite of what I want, if I want them to be in order if A is bigger, basically sorting in descending order, you'll see it'll actually flip the results of my sort. Now it goes from biggest to smallest. And you can make any sorts of sorting comparisons that you need to in order for this to work. Right, one more, and then we're done. Okay. Establish a vector of outfits. We've done that. And use std : for each with a lambda function to provide a personalized fashion statement for each outfit in the wardrobe based on its fashion quotient. Okay, so for each is, of course, a sort of similar to what we've been using. It just requires a little bit of a different format. Duplicate. Okay, so we're not going to sort because it's not really necessary. We are going to use for each. Oops, this should go up here. So, for each is a handy little tool that allows you to kind of like sort, go through all of the elements, but instead of sorting them into order, it applies a function to them. So this is a lambda function. So just like any other lambda function, you want squares, square brackets, parentheses, braces. I'm once again not capturing anything. I don't need to. I do want to have an outfit. That we'll call outfit. I'll call it O actually, just because I can. And then what are we going to do? Here maybe I will use some if statements. If O dot fashion quotient is greater than 80, I'll say, wow, so chic. Else if it's greater than 60, I'll say, looking good. Else if it's greater than 30, I'll say, wow, so mid. Otherwise, please leave. All right, and now we're going to apply this to each of these outfits and see what happens. Oh, what did I mess up? In 39, I have something weird going on. I think it is a missing semicolon. Nope, there's something else I'm missing. Oh, I'm missing a closing parenthesis somewhere. Oh, yes, okay, so this is the end of my function, and then I need a parenthesis to close my for each. Yeah, there we go. Just a little bit of formatting, but no big deal. We got chic, mid, chic, and get out of here. Oh, does that make sense? Let's see. Chic, yeah, this one was high. Mid, yeah, that was mid. Chic, yep. And get out of here for this one. Yep, sounds about right. So for each, a very handy tool that you'll especially see in other languages as well. I think, I'm not sure if C has access to this kind of tool, but C++ for sure does, and definitely languages like Python, Dart, and so on. Very often we'll have some kind of tool that you can use like this one where you can iterate through a range of things and apply a function to each one. And so sort of the nice magic of Lambda functions here is I can just write inside of here this function. It doesn't even have a name in this case. I didn't actually even say that like what the type of this is because it's totally unnecessary. I'm never actually going to call this function ever again. So I'm just going to define it inside of here because once this for each thing is done, I never need the function anymore. So why bother naming one? Okay, that's it. That wraps up our function pointers and Lambda functions. I definitely recommend trying to do lots of practice with these because in particular, I personally find the types to be very annoying. There are some shortcuts you can use. For instance, over here, when we defined our fashion quotient, you actually can, if you like, do the following instead. Hold up, let me copy this. An alternative to writing it out as so is you actually can use auto. Now this is a very dangerous keyword I don't recommend using except in these kinds of scenarios where the function type is really, really convoluted. Auto tells the computer to sort of figure out the type for you. If you have something very convoluted, it's a function that takes a whole bunch of different things and can't really be bothered to write the whole thing out, sometimes it's okay to just use auto. But I wouldn't recommend it for anything that's very simple. If you're just doing, for instance, void functions, just write standard function void empty parentheses. But in the cases where sometimes these do get really, really long, the auto keyword can save you a little bit of effort. Okay, but I think that wraps up this video. Thanks for watching, and I'll see you in class. Bye-bye.